We have a safety valve on the steam drum set for 150 pounds per square inch, located here. It will exhaust out through the roof of the building. We also have a drain line here that came with it that could drain any condensate away. It's actually open here. These boilers could be designed for outdoors, and that would help prevent ice freezing in the outlet line of the safety valve. This valve and line are on the main steam outlet for boiler A. And just above there, you're going to see there's a non-return valve on the main steam out. And you follow the steam line over, you'll see that it connects with the main steam outlet of boiler B. Water from the discharge of B boiler feed water pump flows through this line and comes down and enters boiler B through this non-return valve and inlet valve and enters the shell side of the boiler. The water level is normally about half of this sight glass and is controlled by a float connected to mercury switches that if the level goes down, the pump should start, and when the level reaches its set point, the pump will stop, and so that the level is controlled by on-off of the pump. We have what is called a level column that has a drain valve and a vent. On that are tricocks that are normally closed. You would open these when you are shut down to verify where the water level is. And then we have isolation valves on the sight glass and a sight glass drain valve. The main fuel supply for our boilers is natural gas, which flows through this line and can be isolated with this valve. It comes down and the flow splits off. The smaller line is the pilot line. Pilot line has an isolation valve. This is the pilot pressure regulator. This is the pilot electric shut-off valve. The main fuel to the burner passes through a pressure regulator, which has a vent line on it through the roof, because regulators need to breathe, and it's natural gas. We're inside a building, so it needs to go outside. The next valve is called the main fuel electric shut-off valve. It's normally open, unless for some reason we need to shut the boiler down. There's a very powerful spring in here, and that shuts this valve. The flow continues through the burner isolation valve into the boiler. On the front of the boiler we have the yellow line. It's the main fuel inlet to the burner. The line above it is coming from the pilot. We have a transformer here which sends a signal to the igniter like a spark plug. And this connection is a flame detector rod. It's about 1 meter long, and it goes in there, and when it gets heated enough by the pilot, it will open the main fuel valve and then shut the pilot down. This is the force draft fan. It has louvers which can be adjusted so that we have a blue flame with yellow tips. This is the stack, or chimney if you prefer, which exits the boiler and goes out over and ties into the chimney from a boiler, and the confined flow goes out through the roof. Am I? Yeah, okay. The boiler code requires that you have 2 low-level water shutdown devices. So we have one here, and then inside our pump boiler level control or stop-start is a second shut-off switch. And we also have a high boiler water level shutdown here. This is the operating limit control. You can set a pressure, and when the pressure reaches its set point, this mercury switch tips the other way, de-energizing the main fuel electric valve, which shuts off the flame in the boiler. If for some reason the operating limit doesn't trip when it should, we have a high limit trip set at a slightly higher pressure, which gives us a second chance to trip, which means to shut the flame off to the boiler by closing the main fuel electric valve. Boiler A has a level column consisting of the sight glass with its isolation valves and a drain. This is called the level column drain, and here we have a combination of low-level shutdown and on-off control for A boiler feed water pump with a float, two switches which are enclosed here. The air for combustion is drawn in through behind here, through this screen, and blown by the forced draft fan, and combines with fuel from the burner. Okay. Pilot line enters here. Beside it is the igniter. Here is the flame scanner, which is a light detector. If it can see a pilot flame, it allows the main fuel electric valve to open and ignition takes place. When the boiler starts, we have this pipe being connected to the steam space. Here we have an operating limit controller similar to the one on boiler B. We set the pressure here. When the pressure reaches set point, it trips this switch, which closes the main fuel electric valve located around on the side. If it fails to shut the boiler down, we have the high limit trip set at a slightly higher pressure that will shut it down. Boiler A, because it can be used for process pressure control for operating turbines, has an extra controller called a modulating controller. When the boiler is on automatic, the modulating controller will be set at a slightly lower pressure than the operating pressure controller. The damper motor is mechanically linked to the damper on the air supply and to the fuel valve on the gas coming in. It varies the amount of gas going in, which varies the size of the flame, therefore maintaining the set point for the pressure. Good. Both boilers are drain lines which go to the blow-down tank. When you speak about boilers, anything that's being drained is called blow-down. If there's any contaminants that are heavier than water, they should go out through this line. Thank you very much for joining me today at Lambton College's Boiler Lab.